Hi everyone, welcome back to PRAKASAM tutorials. In this video, I am going to discuss about probability distribution function or cumulative distribution function with example. What is probability distribution function? The probability distribution function describes the probabilistic behavior of a random variable. It defines the probability P of x less than or equal to x for all values of the probability of x less than or equal to x of the event x less than or equal to x for all values of the random variable capital X up to the value of x. Capital X is the random variables. So generally the random variables are represented by uppercase letters, that is capital X, capital Y, capital Z, and values of the random variables are represented by lowercase letter, that is small x, small y, small z, like that. So this is already discussed in my previous video. So the probability distribution function is also called as cumulative distribution function, CDF. CDF is abbreviated as stands for cumulative distribution function. Sometimes it is also called as distribution function of the random variable x. Symbolically, the probability distribution function or cumulative distribution function of the random variable capital X is represented by or denoted by f suffix x of x, capital F suffix capital X of x, and this x is the random variable and this x is the value of the random variable, and the random variable is represented by uppercase letter and value of the random variable is represented by lowercase letter. And the cumulative distribution function is also denoted by simply f of x. So mathematically, the cumulative distribution function of the random variable capital X is given by or defined as fx of x is equal probability of x less than or equal to x. This x is the random variable and this x is the value of the random variable, where small x is the real number. Small x is the real number. The value of the real number is in the range of minus infinity to plus infinity. So now here in this equation, this is the mathematical definition of the probability distribution function or cumulative distribution function. So in this equation, RHS term of this equation, the right hand side of the cumulative distribution function formula represents the probability of a random variable capital X which takes the value that is less than or equal to value of the random variable less than or equal to that of the small x, and that is the definition and mathematical expression of the cumulative distribution function or probability distribution function. Now coming to the example of the cumulative distribution function. Suppose for example, let us take the experiment of rolling pair of two dice. Rolling two pair dice. So rolling pair of two dice, totally there are 36 possible outcomes since each die may show any number from 1 through 6. Now we are rolling a pair of two dice. The total outcomes of the rolling a pair of two dice are 36 and each die may show any number from 1 through 6. So therefore, the sample space or the outcome of the experiment is given by capital S is equal 1 comma 1, and throwing the first die the outcome shows 1 to 6, and throwing the second die the outcome from 1 to 6. So rolling a pair of two dice, the possible outcomes are the sample points is capital S is equal to 1 comma 1, 1 comma 2, 1 comma 3, 1 comma 4, 1 comma 5, 1 comma 6, 2 comma 1, 2 comma 2, 2 comma 3, 2 comma 4, 2 comma 5, 2 comma 6, 3 comma 1, 3 comma 2, 3 comma 3, 3 comma 4, 3 comma 5, 3 comma 6, 4 comma 1, 4 comma 2, 4 comma 3, 4 comma 4, 4 comma 5, 4 comma 6, 5 comma 1, 5 comma 2, 5 comma 3, 5 comma 4, 5 comma 5, 5 comma 6, 6 comma 1, 6 comma 2, 6 comma 3, 6 comma 4, 6 comma 5, 6 comma 6. So totally there are 36 possible outcomes. So rolling a pair of 2 dice. So now here in this experiment, each outcome of the experiment is represented by generally lambda suffix ij, where in the subscript first I, where small I represents number shown on the first die and small j represents number shown on the second die. So rolling a pair of 2 dice, each outcomes may be represented by generally lambda suffix ij. So in this lambda suffix ij, the suffix, the first suffix I represents the number showing on the first die, so that is 1 through 6, and j represents number showing on the second die. Let small n is the sum of the numbers appearing on the die. Small n represents the sum of the numbers appearing on the die. So that is the sum of the numbers appearing on the die, small n is equal to I plus j, and I is the number showing on the first die, that is 1 to 6, and small j is the number showing on the second die, that is 1 to 6. So and small n is the sum of the numbers appearing on the dice, that is n is equal to I plus j. Now here the values of the random variable and the values of the small n are n is equal to I plus j, that values of the small n are n is equal to 2, 3, 4 and so on 12. So that are now here in this sample space 1 plus 1, 2, 1 plus 2, 3, 2 plus 1, 3, 6 plus 6, 12. So the values of the random variable small n is equal to 2 to 12. Next find out the value of the probability. So but we know that the definition of the probability of the event, probability of A is equal number of favorable outcomes by total number of possible outcomes. Number of favorable outcomes by total number of possible outcomes. So find out the probability values of the probability values of 0, probability value of 1, probability of value 2 and so on up to probability of 12. So according to definition of the probability of A is equal number showing on the probability of A is equal number of favorable outcomes by total number of possible outcomes. So first find out the probability of 0. So probability of 0 is equal, in this sample space there is no 0 outcome. Sum of the numbers small n is equal to I plus j. Small n is the sum of the numbers appearing on the die. So there is no 0 sum of the numbers appearing on the die. So the probability of 0 is equal number of favorable outcome is 0 divided by total number of outcomes are 36. 0 by 36 is 0. Next find out probability of 1. So probability of 1 is equal number of favorable outcomes by total number of possible outcomes. Total number of possible outcomes are 36 and the sum of the numbers appearing on the dice, there is no 1, so that value is 0. So number of favorable outcomes are 0. So 0 divided by 36 is equal to 0. Next find out the probability of 2. So probability of 2 is equal, so now here in this sample space experiment the numbers showing on the 2, sum of the numbers showing on the 2, 1 plus 1, 2. So 1 possible chance is there. So the number of favorable outcomes are 1 and the total number of outcomes are 36. So therefore probability of 2 is equal 1 by 36. Next find probability of the 3. Probability of 3 is equal, in this outcome of the experiment, some of the numbers appearing on the dice. We get some 3 is, there are two possibilities, and this is one possibility and this is second possibility. There are two possibilities. Therefore, probability of 3 is equal number of favorable outcomes, that is 2 divided by total outcomes, 36. Probability of 3 is equal to 2 by 36. So similarly determine probability of 4, probability of 5, and probability of 4. Find out probability of 4. So probability of 4 is equal number of possible outcomes. From the above sample space, the sum of the numbers appearing on the 4. 3 plus 1, 1 chance, 2 plus 2, second chance, and 1 plus 3, third. There are 3 favorable outcomes. Therefore, probability of 4 is equal to 3 divided by total outcomes, 36. Next, find out probability of 5. So probability of 5, the sum of the numbers appearing on the 5, rolling a pair of 2 dice, the possible combinations are 1, 4, 4, 1, 2, 3, 3, 2. So the number of favorable outcomes are 4 and total outcomes are 36. Next, find out the probability of the 6. So rolling pair of 2 dice, getting some 6 possible combinations are from the above sample space 1, 5, 5, 1, 2, 4, 4, 2, 3, 3. So these are the possible combinations of getting some 6. The 5 combinations. Therefore, probability of 6 is equal to 5 divided by 36. Next, find out the probability of the 7. So from the above sample point or the sample space, getting the sum 7, the possible combinations are 1, 6, 6, 1, 2, 5, 5, 2, 3, 4, 4, 3. So the number of favorable outcomes are 6 and total outcomes are 36. P of 7 is equal 6 by 36. Next, find out the probability of the 8. So probability of 8, rolling pair of 2 dice, getting some 8 possible combinations are 6, 2, 5, 3, 4, 4, 3, 5, 2, 6. Because the favorable outcomes are 1, 1, 2, 3, 4, 5. Therefore, probability of 8 is equal 5 divided by 36. Probability of 8 is equal 5 divided by 36. And probability of the 9. So probability of the 9 is equal rolling pair of 2 dice, getting some 9 possible combinations are getting some 9 possible combinations are, and this is one combination, this is second combination, this is third combination, and this is fourth combination. So the favorable outcomes are 4 and total outcomes are 36. Probability of 9 is equal to 4 by 36. 4 by 36. Next, probability of 10 is equal rolling pair of 2 dice, getting some 10 possible combinations are, and this is first one, second one, and third one. Through 3 favorable outcomes, so therefore probability of 10 is equal to 3 divided by total outcomes are 36. 3 divided by 36. So similarly, probability of 11 is equal to 2 by 36. Probability of 12 is equal to 1. So these are the values of the probability rolling a pair of 2 dice. Next, find out the cumulative distribution function for each value of n. Now here what are the values of the n? The values of the n are n is equal to 2 to 12. So calculate n is equal to 0 to 12. Find out corresponding probability distribution function or cumulative distribution function values. So we know that the basic expression of the cumulative distribution function is fx of x is equal probability of x less than or equal to x. So now here small n is the sum of the numbers appearing on the dice, that is small n is equal to I plus j, and small n values are 0 to 12 and capital N is the random variable. Similarly, using cumulative distribution function definition, fn of n is equal probability of n less than or equal to n. So calculate cumulative distribution function or probability distribution function for n is equal to 0 to 12. So first substitute n is equal to 0. F of 0 or fn of 0 is equal probability of n less than or equal to 0. So now here n values start from 0. So n less than or equal to 0 means there is only probability of n is equal to 0. So the probability of 0 value is already calculated. So what is the probability of 0 value? Probability of 0 value is 0. So therefore the cumulative distribution function of 0 is, that is fn of 0 is 0. Next, find out the cumulative distribution function of small n is equal to 1. If n of 1 is equal probability of n less than or equal to 1. Now here n value start from 0. So probability of n less than or equal to 1 means probability of n is equal to 0 plus probability of n is equal to 1. Probability of n is equal to 0 value and probability of n is equal to 1 value is already calculated, and probability of n is equal to 0 value is 0. Probability of n is equal to 1 value is 0. 0 plus 0 is 0. Next, substitute n is equal to 2. Fn of 2 is equal probability of n less than or equal to 2. So now here n value start from 0. So n less than or equal to 2 means probability of n is equal to 0 plus probability of n is equal to 1 plus probability of n is equal to 2. N is equal to 0 probability 0, n is equal to 1 probability value 0, n is equal to 2 probability value 1 by 36. So f of 2 value is 1 by 36. Next, n is equal to 3. So fn of 3 is equal probability of n is equal n less than or equal to 3. So n less than or equal to 3 means now here n start from 0. So probability of 0 plus probability of 1 plus probability of 2 plus probability of 3. So probability of 0 to probability of 3 values already calculated, and substitute all these values into here. We get f of 3 value is 3 by 36. So similarly determine f of 4 value. F of 4 value is 6 by 36. F of 5 value is 10 by 36. F of 6 value is 15 by 36. F of 7 value is 21 by 36. F of 8 value is 26 by 36. F of 9 value is 30 by 36. F of 10 value is 30 by 36. F of 11 value is 30 by 36. F of 12 value is 30 by 36. F of 13 value is 30 by 36. F of 14 value is 30 by 36. F of 15 value is 30 by 36. F of 16 value is 30 by 36. F of 17 value is 30 by 36. F of 18 value is 30 by 36. F of 19 value is 30 by 36. F of 20 value is 30 by 36. F of 21 value is 30 by 36. F of 22 value is 30 by 36. F of 23 value is 30 by 36. F of 24 value is 30 by 36. F of 25 value is 30 by 36. F of 26 value is 30 by 36. F of 27 value is 30 by 36. F of 28 value is 30 by 36. F of 29 value is 30 by 36. F of 30 value is 30 by 36. F of 31 value is 30 by 36. F of 32 value is f of 10 value is 33 by 36, f of 11 value is 30 by 35 by 36, f of 12 value is 36 by 36. So these are the corresponding cumulative distribution function values of for n is equal to 0 to 12. And after that, draw the graphical representation of cumulative distribution function versus value of the random variable. Now here what are the values of the random variable? Small n is equal to 0 to 12 and x-axis value of the random variable, that is n is equal to 0 to 12, and y-axis cumulative distribution function or probability distribution function values. Now here n is equal to 0, the cumulative distribution function value is 0, and n is equal to 1, the cumulative distribution function value is 0. N is equal to 0, n is equal to 1, the cumulative distribution function value is 0, n is equal to 2, 1 is 0, n is equal to 2, the cumulative distribution function value is 1 by 36, 1 by 36, and n is equal to 2, n is equal to 3, the cumulative distribution function value is 3 by 36, 3 by 36, and n is equal to 4, the cumulative distribution function value is 6 by 36, n is equal to 5, the cumulative distribution function value is 10 by 36, next n is equal to 6, the cumulative distribution function value is 15 by 36. So these values already calculated. Next n is equal to 7, the cumulative distribution function value is 21 by 36. Next n is equal to 8. The value is 26 by 36. Next n is equal to 9. The cumulative distribution function value is 30 by 36. Next n is equal to 10. CDF value is 33 by 36. Next n is equal to 11, 35 by 36. N is equal to 12, 36 by 36. So this is the graphical representation of cumulative distribution function versus value of the random variable. So from this plot we can observe that the probability distribution function must have a staircase form for a discrete random variable. The probability mass function is one way to describe the distribution of a discrete random variable. The probability mass function cannot be defined for continuous random variable. The main advantage of probability distribution function or the cumulative distribution function is that it can be defined for any kind of random variable. So that is discrete random variable, continuous random variable, and mixed random variable. And this is the concept of probability distribution function or cumulative distribution function with example.